This is a slightly more advanced example of the use of the basic probability principle. It says a card is drawn from a well-shuffled deck of 52 cards. What is the probability of drawing a face card or a heart? Now, the basic probability principle says, let S be an equally likely sample space and let the event E be a subset of S. The probability that the event E occurs is given by this probability statement. The probability the event occurs is the number of ways the event can occur divided by the number of elements in the sample space. And be careful, said before, this only works for the equally likely sample space problems. Okay, first of all, you have to know a little bit about a deck of cards. First of all, there are 12 face cards. The face cards are the cards that actually have faces, and those are jacks, queens, and kings. There are 4 jacks, a jack of hearts, diamonds, clubs, and spades, and the same for the kings and queens. So there are a total of 12 face cards. Sometimes they're called picture cards, but they actually have faces on them. The other thing they talked about is a heart. Well, remember the deck is divided into 4 suits. There are 13 hearts, 13 diamonds, 13 clubs, and 13 spades. So they're asking us to find the probability of drawing a face card or a heart. Now this is where you got to be a little careful. The union rule for probabilities says that if you have an overlap, you've got to subtract off because you counted things twice. In other words, applying the union rule for probabilities here before you do the basic probability principle, or at least in the course of doing the basic probability principle, the union rule for probabilities says that the probability of A union B, and remember, union is OR, is the probability of A plus the probability of B minus the probability of A intersect B. So, the probability that we get a face card or a heart, we'll do FC for face card or H for heart, is the probability of a face card plus the probability of a heart minus the probability that you have a face card and a heart. And that's just acknowledging the fact that if you have a face card that is a heart, you don't want to count it twice. If you just add up the 2 different probabilities, you've actually counted anything that occurred in both of them twice. So, the probability of a face card or heart is the probability of a face card, which is, well, there are 12 face cards out of a deck of 52 cards. That'd be 12 50-seconds, plus the probability of a heart. Well, there are 13 hearts out of 52 cards. That'd be 13 50-seconds, minus, now you got to figure out, well, are there any hearts that are also face cards? Well, there are 3 of them. So you've counted 3 of these things twice. So the probability of getting something as a face card and a heart is 3 out of 52. And so when you simplify that, you get 12 plus 13 is 25, minus the 3 that you've counted twice, that'd be 22 over 52. And that reduces to 11 over 26. So the probability of having a face card or a heart is 11 over 26. Now we'll just say that you could do this without formally writing down the union rule for probabilities. You could just do your count by eliminating your duplicates before you do it and do the basic probability principle directly. So I could also say, well, I know that the probability of a face card or a heart is just the number of face cards or hearts divided by the number of cards in the deck. So if you're counting face cards and you say, well, I know there are 12 face cards and I know there are 13 hearts, but I also know that when I counted those 12 face cards, 3 of them were already hearts. I've counted them, each of those 3 twice. I have to subtract them back off again. And again, the number of cards is 52. And as you see, 12 plus 13 minus 3, 12 plus 13 minus 3, either way, you get 22 over 52, which reduces to 11 over 26. So the point is here, you can think of it either way, but either way, the answer comes out the same. You can think of it as calculating this probability without thinking about this one and this probability without this one, and then take the probability of the overlap, subtract off. You'll get exactly the same thing as if you just said, well, I just want to see how many things satisfy the original condition and put it over the number of cards. Either way, you'll get the same thing. It just depends on what you're most comfortable thinking of.